ECT Tech Nugget, Routing Overview by Dr. Douglas R. Bowie. Today we're going to talk a little about what is routing. And I mean that in a generalized sense of how do packets make it from one side of the network to the other. What does that mean? How does that work? This assumes you've been through the process of ARP. So if you understand the concept of ARP, which is layer 2 frame-based discussions, that's what's going on in each one of these green arrows that we see on the screen, right? Those are the local networks between the routers as we go. And those frames are generated and regenerated as they pass through the routers. You know, they're collected on one side of the router and pass through to the next. So how does the router make the decision when it has multiple decisions to make? How does it decide which way to go through the network? How does it know? And there can be a number of different ways this goes about happening. So as we talk about IP routing, we're going to use more specifically IPv4 routing as our example. That's going to be done by destination IP address. Now, in our headers, as we talked about in class, we collect, source and destination MAC address, and we collect up a bunch of other things. Now, ARP is going to get us our destination MAC address. So step one is going to be going through that process of asking who's got this IP address. I need their MAC address so I can make a frame and send it to my gateway. Whoever's going to be that machine that can talk outside my local network onto the next network. And so we'll create a frame. Inside that, we'll put the layer 2 header. Inside that we'll put the layer 3 header, and then we'll put the data with it, and we'll send it on via a frame to the router, which will pick it up, strip away the frame, and get ready to route at a layer 3. But that's what's happening at step 1 as we're going through that ARP process as we do that on the local network. Step 2, the router will look at the layer 3 IP header for the destination IP address. And it will have to make some decisions at that point, assuming it has multiple routes to take. It will have to decide which one of these are we going to take. Now, typically that happens by having the router go through the IP address and look at any entries in its route table. Every object, every computer will have a route table. There can only be one route table in an object. So it will look at its route table and it will try to match that destination IP address with whatever network most closely matches on the table. And it will work its way from most specific to least specific. And at the end, a router can contain, just like a workstation or a host can contain, a default route, which basically means if I don't know what else to do with this, I hand it off to that. And I shove it to that IP address. And this is pretty typical. We see this a lot on phones and laptops, and client devices almost always use their default route. That's about the only route they really have other than talking to somebody in their local network. They talk to their gateway and it goes out. And in many cases, our local networking is done that way, where we talk about it at an IP level, but it's really all done at a frame level for local networking. And ARP, of course, glues that together. So our next step at that point, now that it's made the decision of which link to take, link 1, link 2, link 3, it will go through the ARP process for the next hop to get the MAC address of the far end's router, and it'll build a frame and, put all the layer 2 frame stuff will go in there for the ARP that happens on this portion of the link. It'll then take the IP layer and the data and shove that all together in the same frame and ship it off down to the next router, and it'll hop down to the next router. Now, a lot of times that will look a lot like this, right? We can see Chris here is one of my Netflix nappers in the back row, and he started to watch a movie. So Chris is at 11.22.33.44, right? And Chris wants to start Indiana Jones. Let's hope he picks a good one. And to do that, he'll need to, reach out to something that's not on his local network. He'll have to go out. The default gateway from Chris's standpoint will be router 1. And we're not going to talk about the IP address of that because we'll leave that for a more detailed discussion of routing in another day. But basically, Chris's default gateway will be, let's call it the southern side of router 1, right? That direct connection from Chris to router 1. And Chris will do an ARP and get the MAC address of router 1 on that side, put a frame in it, put together a frame, put together the layer 3, put together the request and the data, and send that frame off to router 1. Router 1's going to get it. It's going to look at it. It's going to throw away the frame. It's going to look at the layer 3 information and say, oh, you're headed to 55.66.77.88. Well, I know that's not toward Chris, because that's not his IP address, and I don't know where that is, so I'm just going to ship it upstream to my default route. And so router 1's default route is to go to router 2. At that point, it creates a frame. It ARPs for router 2's southern address, Ethernet address. It builds a frame. It takes the layer 3 of the packet that came from Chris and the data that came from Chris, builds a new frame, sends it off to router 2. Router 2 will get it and pretty much do the same thing. We're going to do a lot of rinse and repeat of that, where router 2 is going to get the frame, and throw the frame away. We're going to keep the IP header. We're going to keep the data. We're going to keep looking for what the next route is. And we're going to repeat that process of look through the route table. I don't know what to do. Send it off the default route, basically until we hit that cloud at the top, which I've labeled the internet. At some point, there is no more default route. I'm going to talk a little about that in the next slide. But at some point, a router in the internet is going to say, oh, I know where 55.66.77.88 is. I know what network that's part of. Let me send it down to the Netflix router and they'll deal with it. And so those packets go down a specific route from the internet down to the Netflix router. And the Netflix router looks at it and goes, oh yeah, that's one of mine. I know exactly what to do with that. And it ships that packet again, creates a frame on that network with the Netflix box, creates a frame, puts layer 3 in it, puts data in it, ships it off to the Netflix box, who will unpack it and deal with the data and deal with the request and all that kind of stuff. That's sort of how layer 2 and layer 3 interact. Every hop you see here will be a layer 2 to layer 3 and back. Every single one. When we look at traceroute data, every one of those hops is one of these hops that we're seeing in this diagram. And if there's 30 of them, that means your packet goes through 30 different local networks before it gets to its destination. That's a lot. That's a lot of different hops. That's a lot of frames that get created and destroyed to pass that along. It's the world's largest version of telephone, is basically what happens, if you'll remember that from elementary school. All right, so this internet cloud, and oftentimes we use a cloud to hide things that are very complicated or that we don't want to talk about right now, right? It's more complicated than I want to get into, or it's showing more detail in my diagram than I want to argue about or talk about or whatever. So sometimes we'll use a cloud for that kind of stuff. In our case, the cloud is going to look like this. This is a picture of the core of the internet from 2020. It's kind of a top-down picture, is this spirograph looking thing in the middle. And we're way out on the edges, way out on the edges. The violet color in the center is the absolute core of the internet. And if you were to turn it on its side, it would look more like the upside down ice cream cone that I've got shown here, right? As we go up, there's fewer and fewer and fewer of them. And in many cases, if we're way out at the edges, we may be able to have packets that never hit the core of the internet, right? They go up as far as they need to go. They move over one notch. They come right back down. It's only 10 hops. It's only 15 hops. It's no big deal. Well, if you want to go far, far away, oftentimes you've got to cross the core of the internet. And that means you're going through something that looks like this. Now, we don't manage the core of the internet. We're not super worried about the core of the internet in this class, but it is something you need to know. And the reason for the 30 hop trace routes, about 20 of them are here on each side of that trace route that you do. It would look like this. And you and I are way out on the edges. If you read the edges, you can see there's North America and Africa and Europe and different places like that around the world as we kind of get closer and closer. So if we have services or things that are far away, we're transferring data or email with companies and countries all over the world, that's going to cross through the core of the internet. And it's going to be dense. It's very high speed. It's very expensive. You're going to ask me how we pay for it. And I'm going to say, there are a lot of fees that go on with being an ISP. That's part of what you pay to your ISP. That's why it costs money to do ISPs and things like that. All right, let's go back to our routing discussion. So as we move back here, we're going to replace our cloud with a carrier core. AT&T, Spectrum, other large ISP type companies, they're going to make up that ice cream cone in the middle. That's why we use the cloud at the beginning, because I don't know how many it might go through to get there. That's one of the reasons we run the trace route. The truth is, there is no cloud. We use it visually, but there is always a machine. There is no cloud. There is just somebody else's machine or somebody else's router. So as IT people, we kind of need to know how a bunch of this kind of stuff works. So this is a more accurate representation of the path the packets might take. The last step, as I said, the packet's going to get from Netflix's router to Netflix's server, probably somewhere in a big data center somewhere. And the server's going to receive the frame. It's going to throw the frame away. It's going to look at the header and it's going to say, yep, that's mine. It's going to throw that away. Other than the source IP address, because it's going to need to respond to that. It's going to process whatever the request was or whatever the data is, and it will probably start, because Chris really wants to watch a movie, if you recall, it will generate packets back. It will use the original source IP address from Chris to generate new packets from itself, right, back to Chris. And that's how we get flows that go back and forth and back and forth. And the packets will go the opposite direction, right? They'll follow the default route all the way up to the core of the internet, and then they'll follow more specific routes all the way down back to Chris. Now, we're going to cover this in classes later in the semester. This is kind of a broad overview of how do we route packets and things like that. We're skipping a lot of the detail, but yeah, this should be a nice overview. All right, well, we'll see you next time for the next Tech Nugget.